related, like some cloud security related fundamentals. All right, let me quickly get started. All right, good morning, everyone. So I'm actually super excited for today's session. And this is something I had in mind for a long time, and then I wanted to just like put it out there and give you like kind of like a crash course on cloud security, especially Azure, when there is a lot of advancements are happening in AI space and cloud space. I thought of curating very simple, very simple, simple to understand and implement cloud security architecture, and then some of the tech that no matter if you are working on web or when you're if you are working into database or if you're working into AI, non-AI, I mean, whatever different type of technology or services or company that you work with, as long as they are using Azure as one of their cloud infrastructure, this will like this today's session. I'm 100% sure it's going to be super useful for you. And then the material that I'm going to share with you is also keep it handy. It definitely will be something super useful for you. So I have this session especially focusing on Azure hosted infrastructure, as in secure infrastructure, it's secure architecture for any cloud native application. Um, what are we going to focus today? Oh, before we move on, I kind of have this all the time. I have this template. Uh, Not gonna spend this too much time here, but I'm in the security space for a long time now, and I kind of work in the different security initiative across Microsoft and many other organization, educational or institutions, and then non-profitable institution. Work with work on different startups and work with the different founders and building like this full community. So I go all different type of horizontally. I connect to all different type of folks and share, exchange knowledge on security. So today's session workshop. First of all, before we start our workshop, let's first set up things, and I want all of you to follow along um, and set up certain tools and certain baseline, the ID and some things that I'm going to show here, I'm going to use during this workshop so that we all are on the same page. And I will share most of the material, most of the things that we're gonna like the resources that we're gonna use here soon with this group. So just bear with me. I will go through one by one whatever things that I have planned for today and tomorrow, and we'll get through this. Um, Before we do that, I want you to now, first of all, set up VS Code, download VS Code, download Git, download AZCLI, and download this. Actually, you can leave the last one, the lab source code, but download these other tools, other things. VS Code, set up a VS Code, download Git, and then set up on your laptop, and download AZCLI and install that. It will take probably 5 minutes, maximum 7 minutes. I'll give 5 minutes, 7 minutes to all of you. So download all these three tools, and I'll be back in 5 minutes. All right, I'm back, and I hope most of you downloaded these tools. Um, so let's move forward. Before I start this session, I want to quickly now talk about what are we really going to, what are we going to see, like what are we going to work on this during this session. Um, well, first of all, welcome. And our workshop's goal is very simple. We are going to deploy minimal web application, um, very similar to the real use case, real scenario, where we have a front application like a UI application connecting to backend. It'll have a connection to backend API, and then supporting SQL code operation. So very simple architecture where we are going to focus on applying, first of all, deploying these web application, all three components: database, API, the middleware, and then the frontier or front end uh, static web application, providing a very simple feature, user interaction feature. And once that's done, now what's going to happen once we deploy this? We are going to apply certain security controls on all the three different components. We will start with enabling authentication, and then we'll enable some network security settings, network security rules and firewalls. Then we will also implement some application security related settings and configurations. And then later on, once we have network settings and application security, and then some database security, all these settings enabled, all these Azure services configured. Now we will move towards uh, more like a logging diagnostic related settings, and then the central security solution on monitoring security logging, which is on Microsoft. We have some Defender for Clouds configuration, and then uh, the service that's basically a sub component of or sub feature of the cloud Defender or cloud security space, which is Microsoft Sentinel. Will enable that, and then we'll have a full blueprint of this end-to-end flow working flow on based on the real scenario where we are having like very simple application with no security controls, and then start adding these different security services hosted provided by Azure. So now, why do we really care about these things? Why we really now care about Azure specific tooling or Azure specific security services that we're going to look at right during the session? I want to mention this one thing, that this is not about uh, any specific Azure, like any Azure specific tooling. You will find this similar services on all different competitive clouds, all different cloud providers. So the whole idea is to give you this full picture, full real world scenario, and then what's the blueprint to stay secure. What are the checklist? What's the thing, like what are the bullet points that you're gonna work on when you are going out, on and handling a production? Why you would care more? Because it may, this specific service that you're gonna work on in future, or like probably right now even, this ecosystem can touch human lives, human a public safety, and then some very critical operation, business operation, could be some different type of operation. And you don't want to end up in the situation where the app, you're running full-fledged application but with no as such security settings and control, and not having enough knowledge about it. So that's the pretty much like the idea about this whole workshop and like this hands-on exercise. So the way how it's going to work now, we, as I mentioned earlier, then the whole workshop workflow. Actually, before I jump in, I wanted to just start my camera and just show you that I'm a normal human. I'm not an AI agent, or I'm not AI bot. Just to make sure that you're aware that I'm here. It's just I'm presenting and I have a big screen here, so I'm just like gonna talk at the same time, show you demos, sharing multiple screens here and there, and it's just much easier with a lower bandwidth, consuming lower bandwidth. I'm just turning off my camera, so I'm here. It's not something AI. It's not like presented by some AI agent yet. So with that, let's talk about the phase one. Phase one, we're going to work on the web application, simple skeleton we're going to create on Azure, on Azure environment. I believe everyone here has their Azure student subscription. Do you guys have a student subscription or not?
No,
Arpita,
they don't have.
Okay, so let me share screen. Let me share the link. You, with your Charuset account, you should be able to get a free credit, free Azure credits for prototyping. So I'm sharing just this link in the chat. Take a look at this. You'll get 100 credit. No credit card requires, right? Just add your so only condition here is you really need to log in with your Charuset account, Charuset email account. Do not use any personal account or any personal details here. This program is granted by Microsoft to help student understand and like play with the $100 credit to learn more and grow more, right? So just use this, create your account. This must be the part, one of the things that's we're gonna do today. So if you encounter an issue, just let me know and in the chat, and then we'll take a look what we can do. Okay. So the phase one, once we have a skeleton like fully deployed on the Azure, I will go like those steps. I'll go with you on one by one those steps, and then what are those things, and I'll in a minute. But the second step is going to be phase one, which is identity security, and applying list privilege on this architecture, the basic architecture that we have. where we are gonna enable Entra ID. Then we are also going to enable this RBAC specific model. On top of that, we are going to also enable, enable or remove like a secrets, any kind of secret that you may contain in either database system or API system, right? It really depends on how you are building these blocks. So once we do that, the next step is going to be network segmentation, meaning we are going to apply this network security philosophy on existing infrastructure, existing architecture, and then create different subnets. First of all, virtual net. Then under virtual net, we'll create different subnets to support such security solution scenarios. And then we'll create some private endpoints and then some network security rules to protect our all those three components. And then we will later on then we will apply a firewall. For the firewall, we'll enable a front door. We'll talk about front door, what is front door, and then we'll enable on the front door, we'll then enable rate limiting or rate limiting, as well as the DOS protection and all that. So we're gonna enable those WEF protocols or WEF policies as such. We call like a OASP rule sets, and then there are some other standards as well. So we're going to use that. And then once we have the overall phase two or network segmentation, network security configuration set correctly, then we will move to the second part of it, which is observability and creating a log, diagnostic logging, and creating a class like a security operational cluster where we're gonna that logs will eventually help us firefighting. It will help us investigating any issue, any security incident you may have, like someone is probably attacking web application or trying to hijack API, even pen testing, SQL, identifying all those things. We're gonna see this in observability space, the phase 3, and then the phase 4 is going to be, now that we have logs available, we are going to enable now Defender, which is known, which works on the known issues, known security flaws, and best practices provided by industry, as well as, of course, like Microsoft and a few other governance body. And on top of that, it provides some recommendation to you to remediate these problems. But then we will enable Sentinel on it. And then when we enable Sentinel, it's an additional feature that provides some other out-of-box feature that Defender doesn't provide. So the full picture, if we see end to end, it looks like full blueprint or like a roadmap to build a secure product, secure web product, when you're gonna build secure product or your own application. So with that, let's jump into the phase 1. Phase 1 is pretty simple. First of all, understand the architecture. For this workshop, I brought very simple architecture and simple one, like single application skeleton, which is not going to be the scale. So when you are dealing with the scale, like high scale, where we, like for example, our application, I work in Intune security, and then Intune security is do not have access to the link you provided. Are you creating account, Karishev? Like, are you signing up for this account? Like, you need to sign up. You need to sign up, not log in on Azure.
Is chat window visible to you, Yash?
Yes, I can see chat window.
So I think
I'm just checking 1 second.
All right.
Can anyone else try and then confirm? Is this still is this happening with other people as well, or it's just Krisha? Yeah, I'm not sure what's happening with your specific account, but with this temporary account also, I could log in and I could start process. So probably try with incognito browser, incognito mode, or in private mode. You should see the academic verification screen, something like this.
Academic verification, I think.
Yeah, were you able to like see that screen as well? Yeah, ideally you should be able to see this kind of screen, and then it also automatically validate email, and then will tell you if verification completed or not, right? It just looks for the school email, valid school email from the domain, and then from there you can add your details, and then just click on verify academic status, so it should tell you. Yeah, all right, I'll move forward, but if any other people also have having similar issue, probably like Charles said, the IT team, you'll need to work with IT team to figure out what's going on there. But you should be able to like create your student account and get 100 credits on, sorry, $100 credits on Azure. Any other folks, either from this group having this issue, or is it just Krisha? Ma'am, can you try logging in, or like probably creating your own account?
But then says you don't have an access. Your systems are facing a problem with your account and unable to verify your access. I don't know whether your screen may not get from other. Hey, is there the other students facing the same issue?
Yes, ma'am. Yes, ma'am.
You don't have an access.
So is it?
Like none of
it is
them
possible. Do not have access. So it's possible that
you don't have an access. So.
So it's possible that we may have like from IT team probably have some controls on email itself. So we can't like give a claim. So probably later on you can work with the IT team and see why can't you create like this student account. Let me see if we can have free account. Okay, let's do this way. Let's create a free account, but here okay, so this is another option. this is not a student account. This is also free account, but it gives free account for some time. So for this one, you can't use your like college email. So use your personal email. So create your personal, use your personal Microsoft email. Any email should work. If you have a Microsoft account with your Gmail account or any other email, this should work. So just create your free account with one-time credit. Okay. This should not block you because there is no student verification here. It's like creating your own personal account. So this should not really block you creating account. All right. So let's quickly again move to the architecture part. So yeah, we have a web UI, static web application we're going to use here, Azure Static App. And let's assume here we can have untrusted traffic here. Some common web risks are scanning, some client like some anomalous behaviors, and then there are some injections, input validations requires, etc. These are the things that you will need to implement on your web front. Now the API, which is right behind the web, that's the Azure. We are using here Azure function. That's one of the Azure service, and it provides serverless application deployment environment. So you don't need to then manage like a server or operating system related configurations. Rather, you would focus on the code. You could directly deploy your application code as a function serverless, and this is very flexible in terms of building APIs or even workflows, schedulers, and all that, like automated workflows. We are using simple C# .NET application to build this API, and simple HTML and CSS based front end. And with the API, we have two different flavor of API. API which is get and post. Simple post, and then simple get endpoint, single endpoint. And then we have Azure SQL database with basic tier that supports some security settings and security configurations. And there we're going to use Active Directory based authentication, AAD auth only, so that now you do not have like a password or secret somewhere stored in API or web app. So that's basic structure that we have. And then when we now look at the threat model, so the threat model, what we are trying to protect, what we want to protect. We want to protect some internet-facing API abuse. We want to protect some injections or at the data layer. We want to protect credential scanning, secret leaks, misconfiguration, and some role-based, overprivileged identities, overprivileged roles and authorization, and then some detection. So we're going to enable these things. So now this is the threat model that we are looking at. So when you have this architecture, a simple architecture that you see, when developers see, they see this. But when security engineer would see this, a threat model. And they would go and then zoom in into each of these components, identify what are the possible possibilities, what are the possibilities for security settings and hardening, and what are the potential threats or risk, what is this risk surface, what's the blast radius. And then one by one, we go and then start zooming in into all these different components, and then basically apply some security controls so that it doesn't go that bad, right? So that's pretty much like how it's supposed to how it's supposed to be reviewed in real world. And so what are we going to do? So let's pause here, and we're gonna pause here and then move to Azure. So how many of you, like from this group, have worked on Azure? Maybe just send the thumbs up. Just probably hit one of the smiley, and then I'll know that you worked on Azure or you have seen Azure. You know what is Azure. No one? Okay.
ये तुम्हारे लायक बनना थी.
So the Azure, when we see Azure architecture, the whole cloud architecture, it looks like this. What we have is a tenant. You own full entire environment, like the full entire cloud segregated environment with all these generic services. So the way how the cloud looks like, you have a tenant. So when you now that you started creating your personal account, your Azure account, you are when it will go through, it will like Microsoft Azure team will create a tenant, a personal or private tenant for you, which will look like something like this kind of architecture. And I'll show my own personal tenants, and it'll make more sense later on. Then this next layer, the top level uh, object on and for any of the Azure cloud service starts with the tenant, then management group. Later on, under management group, you can have as many subscription as you want to request. Usually we go and then we create multiple resource group under subscription. These subscriptions you would create in different regions, or either region specific or service specific. It could be any, or component specific. It can be a logical boundary or logical architecture should be should be coming from you, like you as an architecture. So your team designs the whole service scenario and how this entire architecture will look like. But whatever architecture you would come up with, maybe having 100 of subscriptions or thousands of resource group, based on the region, based on the location, whatever you want, it would come like this. Like if you go and zoom in everything and if you're looking the entire architecture from top, it would look like this. You'll have a tenant, you'll own the tenant takes care of creating a group, like a security groups or permissions on high level, if I say. So it creates, the tenant supports identity. uh, Also it supports authentication and authorization, so AAA, right? It supports authentication, authorization, identity, provisioning, group provisioning. When I say identity, now this identity could be user identity, like users, so human identity, or it could be machine identity, like a application identity, or it could be group identity. It could be any different kind. So now the architecture, architects, like the cloud architect or Azure architect, will go and then set up these logical boundaries for you. And then on top of that, now you would go and then um, create your groups and different type of ACLs based on the access that you want to grant. So let's assume I have here a SQL deployed in one of the resource group. Now I want to create access for, probably I'll just pick one of you from this entire list. I'll probably pick Heth. So I want to add a contributor or the owner for this SQL hosted resource or this resource group, I want to ACL like a full permission, read, write, execute everything only to head. So I'll go and then I'll add head here into the resource group level rather than subscription level, because if I add some kind of a rule for head at the subscription or management level, then it's over permissive or over privileged. So this is how the overall like cloud architecture looks like. Now we go and then we take a look at the real like the real scenario or this another subscription that I have, like this the subscription that I own, my personal subscription, where I could see the oracles. Second screen is this one. All right, so let's take a look at this one. If we go to the tenant, Microsoft Entra ID, that's the name of the tenant. So I created this tenant named personal tenant, my own tenant, and then this is how that domain, the full domain looks like. Everyone on the planet will have a in unique tenant ID. So if you create, you should have a unique identity, unique tenant ID. That's how Microsoft or that's how Azure identifies that that's you. And then what I did here, I have like two users created. So I have myself only and my other account. So those two accounts are created as a user, and then I created different groups here. Looks like these. So I have these different groups, and I would like to focus on these two groups, sub contributor and sub owner. So how it works is I created this sub owner group and then added one user, like a one member here. So if I go and then take a look at the total members, then I should see one of my account only. Yeah, my account only. And then if I go to the another group, then I should see two other accounts. I could add like any other accounts, as many accounts as I want. Like a lot of things are here. So I could add as many as account like based on my requirement. So now what I do is like I could go to any of the resource group. So no, actually tenant. So under tenant, we should look for now management group. So management group. Okay, here, right, wrong. Management, and then we have management group. So as you can see, management group will, yeah, it looks like this. Then under subscription, if I go, I have only one subscription right now. And then if I go to the subscription, then under subscription, I would have these two, this view, simple view, where I have like these two options. If I want to just take a look at all the resources, those are under this one giant sub, then I could just go to the all resources and then see everything. But if I want to go segregated resource groups, then this is how it looks like. And I created a couple of resource groups. So I would go to one of this resource group. Let's go to here. And then under one of the resource group, now I have these different resources. These are all different type of resources. So as you can see from the type and then also from the location, everything I deployed into central US location region. And then two things I deployed at global region. So whatever things are available at the global, it takes little time to replicate like all around the globe, and it takes little time to work for the initial setup as well as like when you're updating something. And then central US will take like some generic SLA, whatever SLA that they have. So the way how it works now, I have a server deployed, web application deployed, and I have function app deployed. And this plan works with the function app, and then the database that we see that goes with the SQL under SQL Server. So when you deploy basically SQL Server, it will deploy database as well. And then when you deploy function, it will also deploy this plan, which is nothing but a compute. And this is why when you are deploying Azure function or static app, it deploys this plan as in like a compute, because so that now you don't need to manage like a virtual machine or like a web server, etc. It just like it provides a serverless container for you where you can just now host your application. So these are the general thing that I have right now. Now, based on the architecture that I showed, now I'll go to this function app, and these three different APIs I have. So let's take a look at the function app and go open the function app. Then, okay. Second, I think I may. One second, let me quickly check one quick thing. Okay, actually, in meantime, I want everyone to the trick here to navigate. Here. Okay. Please clone this this Git repo. Clone this Git repo and locally clone this to your local VS Code. All right. I hope everyone cloned the Git repo. So let's start from here. And when you clone this Git repo, so this is the module one that we're gonna do right now. So module one is basically set up web application, and then Azure function, and then SQL database. So when you deploy these three different components, then you'd probably have I'll show you. What you should see is this simple static web app. Okay, right here. Click app. And then static web app. They should see something like this. It's a very simple, web application. If I go and then hit F12 here, and then F12 and then refresh again. So as you can see, it's loading some CSS from this web app only, from this link only, and then it's loading data, fetching this data from the API. Right? If you see this, then I'll open this. It should look like this. So as you can see, we have this app, and then we have this another app, or this is another like API endpoint. It's loading some data from, it's fetching data from the API. So if I go take a look at this now, little more. It's coming from the app.json. So app.js. Okay. All right. So what it does, it takes your remote IP. It goes to this basically endpoint, and when we go to this endpoint, it gives your IP address, your current IP address. And then it goes to it looks for your IP address, and then it calls this API, the internal API, and then fetches. Now we have another feature on this website, but it's nothing but a clicker, right? So if I click, then it should add clicker. So probably, I mean, I can probably share in the chat as well. The people who would like to try out, they should be able to like just open this and then just click here, and then you should be able to see like how it's checking your IP address and then adding clicks, unique clicks for you, and then global clicks. And the more clicks you add, will just basically increment. So it's an incremental counter. And then adding live status, meaning it's just rendering this data live from using API. So now, as we can see, it's like increasing, right? So a lot of clicks are coming, and then my clicks are just this much. So it's going in the backside, in the backend, and then running this API call on API call to these Azure function that I have in the backend. And then from the backend, now what it does, now I have from the backend side, I have this API which is eventually just going to the SQL, and then just inserting or updating the data based on whatever status that I see. So now what happens with this specific configuration? Now it's exposed to multiple different risks because anyone can, as I just shared, right? So many people just added clicks. Just imagine, I mean, it's keep increasing. It can create create chaotic transactions, and it can either flood my system. It can flood. It can inject malicious data also. It can inject malicious pointers and all that. So that's why we're gonna now focus on the network setting. So what it does, I created some automation already. So when you go to the infra, and from the module, if you see, there are 3 modules I created. For the people, those who do not know about BISAP, BISAP is infrastructure as a code programming language. So when you are building any infrastructure, cloud infrastructure, you would need to keep this as a code, because you don't want to lose that service. You don't want to lose that when something goes wrong and then you want to roll out specific change at the scale. You would have this these kind of biceps. So bicep is pretty simple. It's looking into some parameters, the parameters that you would add, and then it has a template. So it looks for specific template parameters by default. If you go and then take a look at Microsoft samples for the bicep, you'll find all these details, whatever predefined values that each of these things are provided. Some values are required, some values are optional. You can create all these things, and then this is all templatized. So once you have this templatized, as you can see, I'm using Active Directory as an authentication. No secrets are there. Enabled encryption, and then also trust server certificate false. So I want to check every single request. Basically, that's what it means. And then connection timeout is 30. So 30 seconds. If it doesn't work out, then it would just time out. So this is like simple example of any specific bicep template or bicep deployment file, and it converts this entire Azure function, as a code. And this comes with a lot of different settings. Like it has some of the settings configured here, some settings here, identity. All these settings are there. Different type of settings are here. This one, another properties, app service setting. Earlier mentioned, it's looking for the shared app plan. So basic idea is to have this full stack deployed with single click, right? And then that's why I have 3 different components. And then main bicep file kind of like takes all those, include all those 3 component one by one. Main file kind of helps you to keep everything neat and clean, and then have one by one deployment, so that if you have a dependency, like how I have dependency on SQL, I deploy SQL as first component, then second component function, which is API, and then third component web application. And then once I'm ready, now I have this particular schema. This is my deployment schema, and this is how it translates my deployment or my compiled infrastructure code for the further deployment. So now this is how the infrastructure code looks like. Now if you go to the README file, I'm clearly focusing on how to deploy this application, which is nothing but a deployment script right here. And if I open this deployment script and this document side by side, you would be able to see what I'm trying to deploy here. And then it's automated based on whatever resource group and then subscription ID and tenant ID you would provide. So with a single click, it will deploy and set up everything. And now let's assume we have a deployment, because this will take some time to deploy these web applications. So I have a pre-deployed web app already created here. So now once I have a pre-deployed app, and that's how it looks like, right? And then now I want to apply some security settings to it. So let's start from applying identity related security setting, and it comes from SQL Server, and then actually I have this documented as well. So we'll go to here, this part. Yeah, this part, and then And then, so here under SQL, you would go to Entra. So under setting, you'll find Entra. Entra ID, you would enable this Entra ID. By default, it's not enabled. So you would enable this Entra ID so that now all the authentication is going through the Entra tenant or AAD tenant that you own rather than any other authentication. And once you have this, now you would also assign specific admin role. You would probably, if you are in production, then you would not apply production role to the user, rather than you would apply this to the group. So you'll have admin group rather than admin user. And let's say now that you have this configuration set, now you would like to add another setting, which is here. Oh, not here. I think here. Okay. I will enable this setting later on. What I need is enable the API and the SQL. In between API and SQL, I want to enable this authentication. This authentication comes as MI, or in this case, system MI. So what I will do is my Azure function is basically here using I'm basically using Azure function as API. So from Azure function, I would first enable my system setting, which is this, and then I will need to now assign this role on the SQL side. And the way how it works, you would go to deployment script, and then you would check for app registration SQL app external. Yeah, this is the one. So you would create, you would like, so on the database side, you would do something like this. So Azure Functions app, it checks first of all whether there's any principal enforced, which is using like basically MI. If it's not, it's creating like MI, and then it adds data reader and data writer role. One thing to focus here, it's giving list privilege. There are multiple other SQL roles available: data owner, data backup admin, data admin, and multiple other roles. There are custom roles as well. There's a audit logger on multiple other roles as well. But then you would only add list privilege role here, so that now your API has access to read and write data from the database, from the table. So that's pretty much what you do for on the SQL side. Now, one other thing that, so now we basically took care of the authentication part. The one thing that is still there, the function app. Function app is exposed to web app as an API, and then web app is connected. Our web app is connected. It's connecting or loading as well as sending data to our API. So now we need to also like enable our identity or some kind of tightly coupled connection, so that my API is not exposed outside. So for that, now I need to create virtual net. And the way how it works, we'll now go to the second part of it, which is network security part. And for the network security part, now we need to quickly, first thing we need to focus on is how this network boundary will look like. Like how we worked on firstly on RBAC to provide a list privilege, to provide specific authorization and whatever access is required to manage Azure resources. First, we focused on that. The second part we focused on was identity or basically authentication between API and SQL. Now I want to make sure that my API and SQL is not exposed on internet, and only web app is exposed. And for that, now we need to bring virtual network. When you create now virtual network, this virtual network kind of like creates a wide, like it's creating a big blast, big boundary. It creates a basically boundary, a huge boundary, and then now you need to scope it down into different subnets. So for that, now when I create a VNet, by default it will create this VNet into a big subset that it can support. Now, within that, the big subset, now we will need to create a smaller subset based on the architecture. So we have one VNet subset here, subnet, which we call VNet subnet, which is basically integrated between API and web, meaning I'm only allowing traffic on API from web only, nothing else. So internet is not allowed, right? And then the second part I'm adding here to the subnet is basically the connection between API and SQL. That's the only connection, outbound connection from my API. So any other request is not allowed, because it is possible in the real world. Someone could hijack your API, and then they could probably perform certain malicious activity from that API, from the API server, and you kind of like now spend a lot of time to trace back. So this kind of scenario, to avoid this kind of scenario, to protect from this kind of scenario, you would come up with this subnet. I hope you would know by, probably now from the subnetting and from the networking fundamental sessions or your course, how this subnetting really works. But subnetting also, it has a proper calculation number of based on the subnet that you create, like the subnet IP address that you create, the number of IP address it will support. So based on the number of IP address that you would really want to support for your scale, whatever based on whatever scale you would have, based on that you would kind of like calculate the required IP address, and then from there you could create the different subnets. So that, and also there are some rules and regulations, some governance body, what IP address could talk to another IP address, all that routing and all that happens within the VNet. So now I have very simple architecture, VNet or network architecture, network flow here. One flow within the one flow. Simply, I want to keep API and web into the one segment or one boundary, logical boundary, and then another subnet or another policy I want to create is in between SQL, my database, and the API. So here, the next step is now to create a network security group, which we call NSG, network security group. It controls traffic. So it's a firewall basically, right? And this network security group actually supports many other things, deny rules, allow rules, and then some network boundaries, some network interfaces as well. So the way how it looks like, we kind of can have this network, yeah, VNet. So when we go and take a look at the VNet virtual network, so yeah, there is one virtual network here, and this virtual network, this is the virtual network that I have created. And then now under this virtual network, let's go one by one feature, because it supports multiple feature, and I just want to focus on right now subnetting. So I would go to the subnetting, and then this is the subnet that I'm talking about. So you would create this one subnet, which is focusing on API part, API subnetting. It supports this thing, And then if you want to enable IPv4, if you enable, then it comes with a different problems. So there is one tricky question. I want to ask one tricky question. Do you, by any chance, identify this range? What is this IP address? Any guesses? Any answers? There are no right or wrong answers. Can you give me any answer in the chat? Like, what is this IP address?
Private.
Yeah, good. So this is a private IP address. There's a public IP address. There's a private IP range. It's designed for netting, and netting is a concept that netting is like a concept that like multiple devices uses. It uses like firewall uses, then our home router that uses, DHCP uses. All these different technology, all these different network technology, it uses this private IP range for simplification, because you don't want to kind of give like a unique IP address to all the devices. That's kind of like defeating the whole point of having unique IP address, because the IP address translates to the backbone or the internet. So whatever backbone that you have, that should have a IP address, and then underneath whatever things that you are connecting, the gateway only like gateway converts or translates your public IP address into the private IP address. So meaning when you deploy now, let's say Azure service as well, it has public as well as private IP address, because at the end, that's also machine, that's also device and network device. Now that subnet you are creating here, so you are creating a private subnet, and you're creating this private subnet, adding just a private subnet. Let's say you're creating some private subnet here. Then underneath the net gateway, I'm just selecting none because I don't have any gateway here. I don't want to create as well. I do want to create network security group, so I created one. There are a couple of network security group I created, and I would like to just focus on this one first. So I selected this. There is no routing table as such, because I don't want to route traffic in between, like within this VNet. So I created that subnet delegation. I'm giving to compute, meaning I'm selecting a compute here because I have a subnet. Subnetting is basically now I'm delegating this to the service that I host here, and I use this a plan, Azure hosted plan. So that's the first one. The second one, second subnet is another subnet, SQL, for the specific to SQL. Now this will really help me now segregate the SQL traffic or SQL and API connection completely outside of the completely protected from the internet, completely outside of the full overall boundary of Azure. And I also have now another one, another security group here. Security group, network security group is nothing but imagine like a policy. So what I'm doing here, I'm creating two different subnets, one for API, one for SQL. And I'm also now creating two different security policies, and then attaching one, like each of these policies correctly to the subnet. So now whenever I'm applying this policy, now this policy is applied to the entire subnet. Why this is important? Because today we have two servers, one API server, one SQL server. Tomorrow I want to scale to maybe 100 servers. It's much easier to manage this way, because subnetting will also taken care by the compute that we attach to, and then the policy that we are going to roll out. It's easy to roll out policy, or it's easy to even clean up those policies. So when you have a subnet, always make sure that you have a one-to-one mapping with the NSG, network security group. Once you have a network security group, you could see like once you create the network security group as a with the subnet, it will look like this. And let's explore first of all SQL network security group. As I earlier mentioned, this is nothing but a policy. So it's a firewall policy. The way how it should work, from the top to top down, all these rules needs to be managed and compute by you, meaning you need to understand what rule should go first and what should go later on. The identify the priority, because when these rules are or the firewall is publishing this policy or these rules, it's actually looking into the priority, and based the traffic it's analyzing based on the priority. So first rule, what is it really doing? Allow SQL connection or traffic from API subnet only. I'm allowing traffic on the 1433, which is SQL port. Those folks who are new to Azure SQL, this is the Azure SQL endpoint, server endpoint. And then source. What is my source here? My source is basically my API subnet, and then destination could be anything. So what I'm trying to do is my inbound rule for SQL, API to SQL, which is SQL. My inbound rule is allowing traffic from the subnet, the API subnet, and destination is any, because that's my SQL server, right? I could have probably later on, I could deploy multiple other servers in future. So if I create those other future other SQL servers, I don't want to manage this destination like a subnetting. So I kind of applied just any, because I want to just keep like internal traffic open. The second rule that I added here is deny all. Deny all meaning if this first rule doesn't match, then the traffic will try to evaluate with the second rule. And my second rule is basically deny all, meaning none of the traffic other than the subnet, incoming subnet or source subnet is this on this port. Other than any of the traffic will just be blocked by default. And then I do not care about any other rule here, because these are all default rules, and it's something that you can't really manage. As you can see, these are disabled. So these are created by default by Azure to protect you from, or protect your network from DDoS, some network related malicious attacks and activity, some threat intelligence activity and all that. So they kind of add some default rules so that you don't misconfigure any of your network. So that is one thing. Underneath, now you would go to the network interface. There is no network interface, as you can see. So SQL has no network interface. SQL specific policy does not have any interface. Here we have a subnet. When we go to the subnet that you linked earlier, right? So it's the same view basically. We'll go back to the subnet, and then we'll go back to the second one, the API security group. There we have some different rules. So we have first rule, HTTPS traffic from internet. I'm allowing only HTTPS traffic. If we go to this particular site again, and let's just add HTTP instead of HTTPS. So right now it's allowed, right? But if I enable this particular rule, oh, is this the one? No, this is not the one. So basically this traffic, it actually looks for the HTTPS. So this is my core browser. Anyway, my machine is basically right now my office machine. So by default, my HTTP request will kind of like go into HTTPS by browser. So that's this rule kind of like it's not going to really work here. The way how it's configured is basically now looking into any other traffic other than 443. So if it's like probably something like this. So if I go and then take a look at this instead of 443, and then if I go and then let's say if I say some other port, which is, I don't know, maybe 80 port, I don't know, something like this, then it should throw an error. Yeah, so like it's basically translating that that policy based on the traffic, that incoming traffic that it comes. So this excuse me. So this specific policy is looking into the web and API, in between web and API. So that's why this is not applied on the web, but it's applied on API. So API is kind of like enforced by the network policy by default, and this Azure function is kind of that example. So I think it's not going to throw. Yeah, so it's always throwing bad request. Anywhere. Sure. Count yeah, it's always kind of throwing bad request only because of network policy. It's not going to run any of this API. But actually, when I open any of the web, then it will host. It will run with the HTTPS because I do not have network policy applied on the web, but rather I applied for the API, which is a bug. I will apply on both. So I'll probably make this change and then push it back, push those changes to the Git. So the thing is, now we have applied that network security group on both our component. It actually comes with this one another configuration that I would like to touch base. And before we do that, I need to move to the next slide, which is all right. So the third part is now okay. So we enabled network security settings. We enabled Entra settings on SQL. We also talked about RBAC related configurations. So let's see the checklist. What did we really talk about? What to do? What we should really enable? So this is a checklist of things when you are running Azure infrastructure. Identity, some baseline requirement, list privilege all the time, Entra ID, and then use Azure RBAC properly with the list privilege possible for user, application, and any other like group access or any other different type of access, because this is the first logical security protocol that you can apply. What does it really do? It protects from any malicious changes, any accidental changes, or any excessive attacks, meaning excessive access, meaning overprivileged access on any of the operation. So clearly, you define certain roles that you need for deployment, operate, and read only, and then clearly separate all these roles into like different groups within the RBAC, how I mentioned earlier. The second part is app to data auth, which is which is nothing but managed identity we used here, system managed identity it's specifically, and we use their to configure authentication between the function app and SQL Server, and it protects us from any accidental secret leak or weak passwords, because it rotates. It relies on authentication and authorization provided by Entra, so it rotates the secret or here in this case I would say AAD token, right? And there is no kind of secret kind of like attached to any of the Azure resource. So now you have a secret-less authentication path. Now the third part we discuss about network setting, network security. Optional for ASG. I did not talk about ASG for a reason. ASG stands for Application Security Group. Application security group you would require when you are focusing on application layer, some controls. It's not applicable in current scenario because I do not have web application authentication integrated. So I'm kind of like working at the network layer and implementing network configurations. But in whenever time allows, probably you would go and then take a look at the difference between both of these, NSG and ASG. It would help you eliminate any of the threat from the lateral movement, or having access at a very high blast radius, having unintentional inbound, outbound access, all these details. So yeah, so basically now when we now take a look at this at the fourth part, which is now enabling WEF or web application firewall, and enabling that enables some certain web application security settings or controls, and that enables eventually us to manage our web application security, or the front door for any of our web application. And this is where the other technology comes into the picture. Azure technology comes into the picture. We talked about identity security. We talked about Entra security. We talked about some database security, some of part we touched on network security. Now we are going to talk about web application security, and on the web application security side, how we can implement WAF on top of whatever things we already have. So for that, I would like to now explore this another area, this another side, which is which is WEF, and WEF works on WEF works on this underlying technology, which is front door. Front door provides Azure front door. It provides multiple other features like firewall, caching, DNS, some DNS settings, and then some DNS protection, DDoS protection, rate limiting, some threshold protection. So it kind of limits a lot of threat exposure when you have a web application, especially exposed on internet. So now, because your application is exposed on internet, you do want to make sure that all the configurations that you are applying on the web application are kind of giving you full control on entire service, because that's your entry gate. That's entry gate or front door for your web service. And now for that, let's explore front door, how the front door looks like. Okay, so would like to now share another screen again. back to Azure portal. So how we have these other components now, we'll go back to network again. Let's go back to just network again. And then from here, there is one thing I forgot mentioning earlier, the private endpoint. So the private endpoint we enabled for SQL. This is one of other feature that VNet provides. Private endpoint helps restricting even the DNS when it comes to database operations or database incoming traffic. So we created this SQL subnet, right? And then we created this private endpoint within within that SQL subnet. And what it does is it uses like standalone network interface, um, virtual network interface again. Within it's all happening within the same VNet, and it creates this private link resource. And as you can see, targeting the SQL server. So if we go and then take a look at this guy, the DNS configuration, it looks like this. So it creates this IP address is coming from the subnet. So the subnet gave this IP address to SQL, right? Assigned this to the SQL, and then we translated that to SQL DNS private link, which is nothing but this entire database link. So what happens is we are kind of translating this DNS with this private link. So now we can use this private link within this VNet. So VNet does not just provide firewall, but it also provides this DNS zoning or DNS configuration. So you could create private endpoint with the within the VNet, and then configure this VNet with different type of apps, so that when you have multiple SQL servers here, it would eventually kind of like translates to one DNS only. Why do you need that? Because if you have one SQL server or multiple SQL server, you do always want to point SQL AG for better availability or high availability. So because of that, we implemented this private endpoint, and the private endpoint also help us protect SQL Server from the DNS spoofing or DNS poisoning. And because it's a private DNS and it's only available within the VNet, so it's not even exposed anywhere else, even if someone creates someone hijacks the API, the function app in this case. So the way now we created this front door, we created this front door, and then the front door, now front door has a couple of settings. I do want to focus on one or two settings here. We can explore like all these other settings, but I want us to focus on this front door manager, and that kind of give us full picture of what are we trying to do. Like this front door we enabled. So we have this web application, but we kind of we have this front door configured that is available globally. So now behind this front door, we have these two different routes created, and these two different routes are coming from the app itself. We provision these route. How these route looks like, if we open this route, one of the route behind the front door endpoint, we have so it looks for the pattern matching from the URL. It also this is where this is why earlier the front door was accepting HTTP and HTTPS. If I enforce this to HTTPS, then it would not accept any HTTP traffic. And then as I earlier mentioned, by default, my network configuration that I deployed here, it enables HTTP, redirect all the traffic to HTTPS. Origin, so origin here is API origin, and basically when I go back here now into the front door, and then if I go to origin group, then I have two different origin group. You would first configure this particular setting, origin group. So you are creating this origin, meaning the endpoints behind this front door. So front door is going to be your gate to the service, and then behind this service you can configure now different type of routes. So one of this route, if we go and then edit, then it would show the similar the similar thing. The view that it shows, it's behind this, it looks for this function app, and it also check the health endpoint, and based on this endpoint it kind of enables the origin. So this was the function app, right? And this one is a static app. So if I go and then take a look at this one, this would look for the static app, right? The same app. This is actually a different app. So this app is, yeah. So as you can see, right, I have two different apps, but basically I'm looking into another app, and this app is configured on. This is also configured on HTTP port 80 and HTTPS 443. And once you have both of these origins, these are nothing but our destinations. And once you have a destination, you can configure your custom domains as well with the custom certificates. So your front end will contain multiple other things, not just these configuration. You can add different route and all. Now you can configure here WEF underneath WEF. Underneath WEF, we can now have a different option to create these policies. So I created this policy. As you can see, the view is pretty simple. I created this WEF policy, security policy, and this click app policy associated with the web app. So if I go and click on this policy, this will show me all different type of rules. It has a custom rule. What is it? Custom rule. Okay, rate limiting rule. I added this rate limiting rule. Probably if I add 10, let's add 10. It may take some time, but this custom rule for rate limiting, I have some other policy, other Azure policies, Azure web policies already implemented based on some different rules, like how I have different Intel and SQL, and then bad bots, unknown bots, all these things. Like it has all these different type of protocols. The policy groups, and you could set these policy either enable or disable. You could change action as well, either allow, deny, redirect, or capture, this kind of thing, right? So these kind of detail I could add, like here if I add oh, this is enabled, right? Okay, so action, and then deny, instead of deny, add captcha maybe. So added this rule. This is looking for click app. Let's see, go and take a look at this front door. Then probably I'll go here. Then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. Let's see. It's trying to. Usually, as I earlier mentioned, couple of Azure resources takes little longer time to replicate these rules, especially global. So if you are changing this thing in on one of the servers, it takes longer time initially, but once it's out there, then it would then support pretty fast. But right now, yeah, it will take some like probably 5 minutes, 10 minutes, something. And then once you have, then you have like that kind of rate limiting, rate limiting threshold. And like something similar, basically whatever policies that you're adding for the web application firewall. And what I configured now is after NSG, the settings, we enabled firewall. With the firewall, as I mentioned, we would go with the Azure front door and enable WEF, and then some routing configuration, and then enables some different type of settings here. So that way, you would create your global profile, global endpoint, and rather than like one single web endpoint, you would then share your front door endpoint. You configure this endpoint with the domain. And with that, so now this is this much what I had for today. I talked little faster today, but lot many things I covered. So quickly just recap what we covered today. We talked about Azure, like simple skeleton, started with the skeleton web application. Then we talked about Entra authentication site, RBAC, how RBAC is designed, how cloud architecture looks like, how Azure cloud backbone looks like. Then we talked about like how we would enable SQL and API, like authentication between SQL and API. Then we talked about how we could then enable how we could enable the NSG or network security. Before you create network security group policies, you would first create the VNet. How do you configure VNet? What subnets, and how do you really decide subnetting as well? So those things you would add. And let's assume that you have these configurations set for your NSG and for your VNet. Then you would enable one more layer there in front of your web, and that's basically your web or web application firewall rules. And once you have now web application firewall rule configured, that's where you would need to deploy front door. And front door comes with a different other features like rate limiting, custom settings, DNS settings, and some other web application related security features. That's pretty much what we today cover. Tomorrow we are going to cover security logging, diagnostic settings, some Azure Monitor and Azure security monitoring related concepts and philosophy on observability. We'll also talk about Defender for Cloud, and then enable some other security features like Sentinel, and then central SOC on top of whatever configuration we're going to build, security settings we're going to build. So all these things we today deployed, or today I kind of explained everything. I pushed all these details, all these automated scripts and all that to set up, and then set up in your lab and then play with it. Just probably set up one by one, go through one by one of these things, and then understand like whole workflow. How does it really work? End to end. And once you do that, tomorrow I want to focus more on the security logging side, which is more on the governance and then monitoring, detection, and prevention side. We'll talk about anomaly detection on API, web, and SQL. today we only implemented WAF rule, or we just deployed WAF. Tomorrow we're gonna apply some rules, create some rules, and then see how it looks like when in real world, when any malicious activities are detected. So yeah, that's pretty much what I had for today. And we talked about this. We actually all talk about all this. So if you need these details, I can share this presentation. I was kind of like going following through and then sharing my screen and showing everything. So we talked about all these details. Any questions that before I let you go? Anyone? Any question that I need to take right now, and just put it in the chat or maybe speak up. I'll probably come up with the answers tomorrow. Anything that you want me to answer? Nothing? Is it too advanced for you guys, like for this audience, for this group? Is it something like, how many of you really learned something or saw these things for the first time? Maybe just give hands up.
They may even you don't need to. They may even.
Yeah.
They may
No need to. Yeah. You can just probably just say, yeah, I just heard that for the first time. There's nothing wrong with it. It's good that you are learning these things in college. So you heard this, you saw all these tools, this technology for the first time, right? So the whole idea is to take this learning, take the lab that I created, because if you go to the Microsoft Learning, and if you just go through like some video tutorial, right, you will not be able to see the full blueprint. You will never be able to understand every single security things in one shot. So the idea from this workshop is to understand, first of all, cloud architecture, how in real world, when we deploy any real application or real business service, how does it look like, what are the components, and how it's going to be managed. When you deploy a full baseline, then how does it look like, and then what are the security flaws it may have. Then you would just go apply your security expertise on all different area one by one, and then you kind of like mitigate those risks ahead of the time before you're going into the production. So tomorrow, if anybody in real world, real industry, if people are asking you, have you heard about a web application firewall? Your answer should be yes. You have attended this Azure security workshop, and then you know that web application firewall is something you can configure on your front door, and front door is Azure service that supports API, web, all other integration as a front gate on your infrastructure. So that's the whole idea. That's the summary from this workshop. This is where I will stop, and I'll let you speak, Arpita. Arpita?
Sorry, am I audible now? I mean, I'm just transferring the devices.
Okay, no worries. Yeah.
All right. So I think this will be, we need looking for the also recommendations or any suggestions from this group also, because you guys are closely work on the same domain and take as many as benefit from him. So I think, yes, you may also guide them for, facing any company's interview or looking for the portfolio to build upon the same domain for the further nurturement for facing any company's interview and appearance in that against the company people. That will be definitely help them out, because after these semesters, they need to be join up the internship. So maybe depend on 3 or it's a 1-2 months, depending on how they are choosing with it. So if anyone would like to work with you for the certain, the task or definitions you might guys have done before it as a prerequisite task or work, so you may join with the group also. And that you can make it open to the group also, the students group. They may happy to work out with you. Am I right, Hate?
Yes, ma'am. Of course.
So you may brush up them.
Is this group a mix of multiple like different years? I mean, sorry, different. What's the audience? I'm actually trying to understand from the year like 24 CE. I'm understanding that these are all from CE student, but what year?
Third year.
Third year. Okay.
Third year, the mostly.
Okay. Okay. So this is the perfect time for you, everyone, to pick up a cloud security, cloud architecture, and apply whatever concepts that you have learned or you have been learning right now within your program. The question you should always ask and leverage all your faculty. I mean, they are experts in all of their area. So leverage their expertise, understand the fundamentals of these domains. Like I still remember as a student, I don't know how many years back, probably 10 plus years back, I asked stupid questions on operating system and database, and also Java when Arpita ma'am was taking lessons, right? Taking those sessions. So there is no such, at this point, there are no such stupid questions anymore. If you are going into any of the field, this cloud security is not optional anymore. It's an essential technology skill. It's an essential skill in any area. If you are so much passionate about data science, data engineering, security, security architecture, security scanning, like pen testing, red team, blue team, purple team, engineering, infrastructure, whatever you want to work on, and device, anything, right? This cloud security or cloud in general, cloud computing and cloud security, edge computing, all these things are going to be and is currently an essential skill. So leverage probably your connections, leverage professors, and ask questions if you have, because I mean, this is a very good platform. I wish we also had this kind of sessions directly from Azure security engineer.
Exactly. Agree.
Yeah. Like you have some question about some Microsoft product security specific thing, you can maybe just drop a message to Arpita ma'am or maybe directly me on LinkedIn, and I can guide you with the path for the area that you are looking for. Yeah, I'm happy to help.
Yeah, so tomorrow we can take away in this way, like take in just general from your end what you prepare for them for initial 1 hour, and 1 hour we can keep it open forum discussions, because what they are raising with their mind, so they turn up with some exercise point of view, okay, what they want to raise a questions against you for the specific domain. Is it work?
Yeah, absolutely.
Yes, it will work, ma'am.
So that make it easy. What they have come up with the mindset, we don't know even neither. We don't know. So maybe you can guide them in a very streamlined way.
Yeah, totally. And even for tomorrow, I do not have too much content as such to cover. Like how today's session was very heavy content, because I was starting from the entry level, like completely new, right? And tomorrow we will move forward from here. I'll have a very little content, but I want you to now spend time on the GitHub repository that I shared with you. Go through each of these labs one by one. There are 3 labs. I want you to do this, or at least, if I understand that maybe you have some issues with your Azure account and all, probably read through all the labs that I wrote and try to understand what these labs, each of these lab activity is trying to achieve and how it will help you. Like understand those concepts, bring questions tomorrow. Like if you have questions tomorrow, like bring those questions, I'll try to answer.
Yeah, that works certainly. Absolutely
Awesome.
fine.
All right.
Fine.
All right. Thank
All
you.
right.
See you
Thank you
tomorrow
so
then.
much. Yes. Yeah. See you tomorrow. You're taking your long time.
No. All good. All good.
It's
All right.
almost
Thank you.
midnight
Bye.
over there. Yeah. Yeah.
It's
Certain.
actually 11 something. Yeah. 11
Fine. Then
somewhere around
enjoy.
11. So
Done.
yeah. All right.
Then meet you
Bye.
later.
Yeah.
So
See you.
bye. Take care.
Bye.